How does interrupt handling redirect CPU execution? Imagine your computer is a busy restaurant kitchen. The chef is focused on preparing a meal, but suddenly, a waiter shouts for an urgent order. This is similar to how interrupt handling works in a computer. It allows the central processing unit to pause its current task and respond to important events. When a hardware device or software generates an interrupt signal, it sends a message to the central processing unit through an interrupt controller. This controller prioritizes multiple interrupts, ensuring the most critical ones are handled first. The central processing unit detects this interrupt while executing instructions and finishes the current instruction to maintain program integrity. Next, the central processing unit saves the current execution context. This context includes the program counter, which is the address of the next instruction, central processing unit registers, and processor status flags. Saving this context is essential because it preserves the exact state of the interrupted program. This way, the program can resume correctly after the interrupt is handled. After saving the context, the central processing unit looks up the address of the appropriate interrupt handler in an interrupt vector table. This table maps interrupt signals to their corresponding service routines. The central processing unit then sets the program counter to this address, redirecting execution to the interrupt handler. The interrupt handler executes the necessary code to service the interrupt. This could involve reading data from a device, processing input or output operations, or handling software requests. During this time, the central processing unit typically operates in a privileged mode with interrupts disabled. This prevents other interrupts from interfering with the current task. Once the interrupt handler completes its job, it restores the saved context from the stack. This includes the program counter and registers, allowing the central processing unit to return to the exact state it was in before the interrupt. Execution then resumes from the interrupted instruction, making the entire process seamless for the running program. In embedded systems and microcontrollers, this mechanism is vital for real-time responsiveness. Devices like keyboards, sensors, or communication interfaces can signal the central processing unit immediately when attention is needed. Efficient interrupt handling improves system performance by avoiding constant polling and reducing central processing unit idle time. In summary, interrupt handling redirects central processing unit execution by detecting an interrupt signal, saving the current program context, loading the interrupt handler address, redirecting execution to the interrupt handler routine, executing the handler, and restoring the saved context. This process ensures timely responses to critical events while maintaining program continuity and system stability.